This is a video of all the working out of all the questions given in the GCSE Pythagoras booklets. If we look at question number 1, it says a rectangular television screen has a width of 45 centimeters and a height of 34 centimeters. So we have a width of 45 and a height of 34. Work out the length of the diagonal of the screen. Give your answer correct to the nearest centimeter. The question says that it is a rectangular television screen, which means that we have 90-degree angles. All the interior angles of a rectangle are equal to 90 degrees, which means that over here we actually have a right angled triangle. So we are actually just calculating or determining the diagonal. So the diagonal in this case is the hypotenuse, so I'm just going to abbreviate it as D for diagonal. So the diagonal squared is equal to side 1 squared plus side 2 squared. Side 1 is 45 squared plus side 2, which is 34 squared. So the diagonal squared is equal to 45 squared plus 34 squared, comes to 3,181. But I'm not looking for the diagonal squared, I'm looking for the diagonal, which means that I'm going to square root both sides of this equation so that the square root cancels with the square. So the square root of D squared is D, or the diagonal, is equal to the square root of 3,181 rounded to the nearest centimeter becomes 56 centimeters. Next question. We have a right angled triangle given to us, and it says calculate the value of y. Give your answer correct to 3 significant figures. So we're going to round to 3 decimal places. So we have y. We can see that y is not the hypotenuse of this triangle, which means that it's one of the shorter sides. So we do have a shorter method for working out one of the shorter sides of a right angled triangle. And that is, take the shorter side that we're looking for. In this case, it's y. So that means that y squared is equal to, now the only thing you have to remember is that you have to use the hypotenuse first for the shortcut. So that is 10 squared. So don't forget to put the 10 there. And then instead of plus, we are going to do minus and the other side, which is 4.5 squared. So the theorem of Pythagoras states that the square on the hypotenuse is equal to the sum of the squares on the other two sides, which means that therefore if we're manipulating the formula or we're changing the subject of the formula, we are able to say that one of the other shorter sides is equal to the hypotenuse squared minus the additional side squared. So this means that y squared is equal to 10 squared minus 4.5 squared comes to 79.75. But I'm not looking for y squared, I'm looking for y by itself. So that means that I'm going to square root both sides. The square root of y squared is equal to y. And that is equal to the square root of 79.75 rounded to 3 significant places is 8.930. Don't forget your unit, centimeters. The next question says that a frame is made from wire. The frame is in the shape of a rectangle, 30 centimeters by 20 centimeters. The 2 diagonals of the rectangle are also made from wire. The question says calculate the total length of wire needed to make the frame and the diagonals. Give your answer correct to 1 decimal place. Alright, so now what we're going to do is we want to find out how much wire is needed, the total amount of wire that's needed not only for the frame but for the diagonals as well. Now there are 2 diagonals. The shape is a rectangle, it's given to us in the question, and a rectangle we know has equal diagonals. So all we need to do is find the value or the length of one of the diagonals, and then we will be able to double it to get the value of both the diagonals together, or just add the 2 to each other. We are going to start by determining what the hypotenuse is. How do I know that it's a hypotenuse? How do I know that it's a right angled triangle? Because it says it's a rectangle and the interior angles of a rectangle are 90 degrees. So we know that the diagonal, so I'm going to say D again, the diagonal is the hypotenuse, so D squared is equal to 20 squared plus the other side, which is 30 squared. So we know that D squared, or the diagonal squared, is equal to 20 squared plus 30 squared, which is 1,300. But I'm not looking for D squared, I want D by itself, so I'm going to square root both of these sides so that the square root cancels with the square. The square root of D squared is D, equal to the square root of 1,300 is 36.1 centimeters. So that is the length of the diagonal. But the question says calculate the total length of wire needed. So that means that the wire is needed for 2 lengths, 2 widths, and 2 diagonals. So therefore, the total wire will equal 2 of the lengths, which is 30, plus 2 of the widths, which is 20, plus 2 of the diagonals, which is 36.1. So therefore, the total wire that is needed, rounded to 1 decimal place, is 172.2 centimeters. If we look at the next question, we have a quadrilateral ABCD. Angle BAD is 90 degrees, so we have B to A to D. So BAD is this angle over here, is 90 degrees. BCD, B to C to D, so I'm talking about this angle over here, is 90 degrees. AB is equal to 9.8 centimeters. AD is equal to 3.6 centimeters. BC is equal to 8.4 centimeters, and it's asking us to calculate the length of DC. So if I look at the length over here, that is DC, I've highlighted it. Now we have, in this case, 2 triangles. We have triangle number 1 and we have triangle number 2. Now if we were to imagine ignoring triangle number 2, then we have a right angle triangle ABD. If we look at ABD, we know that we have the 2 shorter sides, so we would be able to therefore calculate or determine the hypotenuse or the length BD. Once we have BD, whatever it may be, then I would be able to ignore triangle ABD like this, because I would then have this length, I'd have the shorter side, which means that I would be able to calculate the second or additional short side of the second triangle. So I'm going to start by stating in which triangle I'm working. So I am in triangle ABD. Alright, in ABD I'm calculating the hypotenuse, so that's BD. So BD squared is equal to the short side, AD squared, plus the other shorter side, AB squared. So BD is what I'm calculating, so I'm going to keep that as BD squared is equal to AD, which is 3.6 squared, plus AB, which is 9.8 squared. So I know that BD squared will equal, if I say 3.6 squared plus 9.8 squared, I get an answer of 109. But I'm not looking for BD squared, I'm looking for BD by itself, so that means that I'm simply going to square root both of these sides. The square root of BD squared is BD, so BD is equal to, and now instead of writing out the decimal of the square root of 109, I'm actually just going to keep it as the square root of 109, because this is part of a second question. So this is the first part of the whole question, so I need to keep all my decimal places. So the easiest way to keep all my decimals would be to make it the square root of 109 and keep it that way. So now I have BD equal to the square root of 109, which means I can now calculate DC. So I'm going to swap triangles, so now I'm no longer in triangle ABD, now I'm in triangle DBC. So I know that I am looking for DC. So DC squared, that's one of the shorter sides, it's not the hypotenuse. So the shorter side is equal to the hypotenuse, and in this case the hypotenuse is BD. BD squared minus the other short side, which is BC squared. So you can see that the original Pythagoras formula is the hypotenuse is equal to side 1 squared plus side 2 squared, and the adjusted formula is that side 1 or 2 squared is equal to the hypotenuse minus the remaining side. So DC squared is equal to BD, which is what we just calculated, of square root 109. But it's substitution, so squared minus BC, and BC is 8.4. And that is also squared. So I know that DC squared is equal to the square root of 109 squared minus 8.4 squared gives me 38.44. But I'm not looking for DC squared, I'm looking for DC by itself. So I'm going to square root both sides. The square root of DC squared is therefore DC. And that is equal to the square root of 38.44 becomes 6.2 centimeters. If we look at the next question, we have surds in our length. So we have ABC, triangle ABC, it's a right angle triangle. The question says all measurements on the triangle are in centimeters. ABC is a right angle triangle. K is a positive integer. So we know that K is a positive integer, and it says find the value of K. Alright, so now what we're going to do is we have K on our diagram. K is over there. K is not the hypotenuse. The hypotenuse is the longest side of the triangle and the side opposite the right angle. So that is the hypotenuse. So we're actually looking for one of the other sides. So we're looking for one of the short sides. So I can say that AB squared is equal to, if I'm looking for one of the short sides, it's equal to the hypotenuse, which is AC squared minus the remaining short side, which in this case is BC squared. AB I have as K being squared equal to, now AC is the square root of 3 plus the square root of 15, but that's squared, minus BC, which is 3 plus the square root of 5, and that is also squared. So I'm going to have K squared equal to, when I do the square root of 3 plus the square root of 15 all squared on my calculator, I get 18 plus 6 root 5 minus 3 plus 5 root 5 all squared becomes 14 plus 6 root 5. So I have K squared equal to 18 plus 6 root 5. Then that minus sign is going to change the signs inside the bracket. So I have minus 14 minus 6 root 5. So now what I have is I have positive 6 root 5 minus 6 root 5. So those are going to cancel. So I'm going to have K squared equal to, then I have 18 minus 14, which is 4. I don't want K squared though, I want K by itself. So that means that I'm going to square root both sides. So I'm going to square root K squared and 4. So therefore K is equal to 2 centimeters. Next question, now I have a circle. In the diagram, O is the center of the circle. So the minute that I have O being the center of the circle, that means that I have radii. And I'm just going to start by identifying my radii. And those radii are therefore equal to each other. So I know that OC is also equal to 6. Also keep in mind that a radius is from the center of the circle to the circumference of the circle. So that's OC and OA. It's not this part of the line BC because that's outside of the circle. A and C are points on the circumference of the circle. BCO is a straight line, and then it says that BA is a tangent to the circle. Now the fact that BA is a tangent to the circle means that we have a 90-degree angle over here, because we know that the radius is perpendicular to the tangent. That's one of our circle theorems. AB is equal to 8 centimeters, OA is equal to 6 centimeters, and the question says work out the length of BC. So in order to calculate BC, I am actually going to calculate OB, because OB is the hypotenuse of the triangle, which means that I can easily calculate or determine the length of OB, and then I'm going to subtract this part of OB from it, because I know that that part is equal to 6. So I know that OB is the hypotenuse, it's the side opposite the right angle. BO squared is equal to side 1 squared, which is OA, plus side 2 squared, which is AB. So BO squared is what I'm looking for, is equal to OA, which is 6 squared, plus AB, which is 8 squared. So that means that BO squared is equal to 6 squared, which is 36, plus 8 squared, which is 64. So that gives me 100, but I'm not looking for BO squared, I'm looking for BO by itself. So in order to get it by itself, I'm going to square root so that the square root cancels with the square. So I can say that the square root of BO squared is BO is equal to the square root of 100, which is 10 centimeters. But I know that CO equals OA, which equals 6 centimeters. Why does CO equal OA? Because they are radii. So therefore, I could say that BC is equal to the full length, which is BO, minus that little bit of the radius, which is CO. So that means that BC is equal to BO, which is 10, minus CO, which is 6. So BC is equal to 4 centimeters. Here is a part of a field. This part of the field is in the shape of a trapezium. A farmer wants to put a fence all the way around the edge of this part of the field. How much fence will he require? Alright, so we have the shape of a trapezium, and it wants to know how much fence he will require around the edge of the field. So that means that it's the perimeter. So we're going to take this 11, this 10, this 18, add it together, and then that means that we are just short of that slanted or sloped line over there, the length of it. Alright, so in order to calculate that, we are going to create a right angled triangle. So we are going to draw in a right angled triangle over here. So that's my right angled triangle. Because it's a trapezium, it means that those sides are parallel to each other. It also means that I've now created a rectangular shape, which means that that side is equal to that side. So that means that I have 10 meters for the base of this triangle, the one side of this triangle. So I am needing to calculate or determine this slant over here, which would be the hypotenuse. So I need this part of the line that I'm highlighting in red. But I know that the whole line is equal to 18, and this part of the line is equal to 11, which means that the part of the line that I need for this triangle is equal to 18 minus 11, which is 7. So I have 7 over there, and I have 10 for the base, which means that I can now calculate this diagonal or this hypotenuse. So the hypotenuse squared is equal to side 1 squared, which is 10 squared, plus side 2 squared, which is 7 squared. So the hypotenuse squared is equal to 100 plus 49, which is 149. I'm not looking for the hypotenuse squared, I'm looking for the hypotenuse by itself. which means that I need to square root both sides. The square root of h squared is equal to h. And the square root of 149, I'm going to keep it as the square root of 149 for now. It's asking for how much y are needed, is equal to the diagonal that we just calculated, which is the square root of 149, plus the remaining lengths. So we have 11 plus the bottom, which is 10, plus the right hand side, that full length, which is 18. When we add those together and round to one decimal place, we are left with 51.2 meters. Next question says that ABCD is a trapezium. AD is 10, AB is 9, DC is 3. Angle ABC is equal to angle BCD, which is 90 degrees. Calculate the length of AC. Give your answer correct to 3 significant figures. If we are looking for line AC, we can see that there is no line AC, so if I were to draw it in, I would create triangle ABC. Looking at triangle ABC, we only have one length in triangle ABC. We have this 9 centimeters. So we won't be able to calculate the hypotenuse because we need 2 of the 3 sides in order to use Pythagoras. If I look at triangle ADC, that is not a right angle triangle. So we can't calculate the AC as the hypotenuse of triangle ACD, which means there has to be something else we can do. We have a trapezium, which means that I am going to separate this into an additional triangle. So I am now separating it into triangle AD, and then I am just going to make this E. So I'm creating point E. All right? Because by doing that, because I have a trapezium, it means that the sides are parallel to each other. So these sides are parallel to each other, which means that I can know, or I would know, that ED is equal to BC. Now, as you can see, we would need BC in order to work with the red triangle. So that means that I can calculate ED, the length that I've just created, this length here, ED. It will be the same as BC, and then I can calculate AC. So I'm going to start by saying, draw line ED. Alright, so I'm going to start in triangle AED. I know that I am looking for ED. So ED is what I'm looking for. So ED is one of the short sides, so that is equal to the hypotenuse, which is AD squared, minus the other short side, which in this case is AE squared. But now I need to find out what AE is. So if I'm looking at line AE over here, I know that the whole line is 9 centimeters. So from A to B is 9 centimeters. But I can see over here that this line is 3 centimeters. I have DC equal to 3 centimeters. So that means that AE is 6 centimeters, because it's the full line AB, which is 9 centimeters, minus this part of the line, which is 3 centimeters. So that's why it's left with 6 centimeters. So that means that ED squared is equal to AD squared. AD is 10, so 10 squared minus AE, which is 6 squared. So ED squared is equal to 10 squared, which is 100, minus 6 squared, which is 36, so that gives me 64. But I'm not looking for ED squared, I'm looking for ED, so that means that I can square root both sides. So I'm going to square root the ED squared as well as the 64. The square root of ED squared is equal to ED, and that is equal to the square root of 64, which is 8 centimeters. So therefore BC equals 8 centimeters because they're equal to each other. So if BC is equal to 8 centimeters, I can take this 8 and I can write it onto my diagram. So now I can work with this triangle that I'm coloring in now. So I ignore everything else that's on the diagram. And now I have triangle ABC. I have the length AB, I have the length BC, which means I can calculate AC. So I'm going to say, in triangle ABC, I'm looking for the hypotenuse, so AC squared is equal to side 1, which is AB, squared, plus side 2, which is BC squared. So AC squared is equal to AB, which is 9, squared, plus BC is what I just determined, is 8 squared. So AC squared is equal to 81 plus 64, which is 145. But I'm not looking for AC squared. I'm looking for AC by itself. So that means that I'm now going to square root both sides. So the square root of AC squared is equal to AC. And the square root of 145 rounded to 3 significant figures is 12.042 centimeters. In the next question, we have a rectangle that is 2 centimeters by 8 centimeters. The 8-sided shape below is made from 4 of these rectangles and 4 congruent right-angled triangles. Work out the perimeter of the 8-sided shape and you must show all your working. So now I have each of these rectangles are 2 by 8. So I have this rectangle over here, 1, 2, 3, and 4, are 2 by 8. So that means that the shorter sides are 2 and the longer sides are 8. So that means that this is 2, that is 2, 2, and 2. So far I have that part of the perimeter. So therefore I would want to determine the hypotenuse of each of these triangles. Now the fact that they are congruent triangles means that I actually only have to determine one of them. So let's say I'm working with this one over here. If I want to work with this triangle, I need to know what the lengths of the sides are. So it consists of a full length of this rectangle, which means that this is 8. But then it consists of only part of this second length of this rectangle here. And we know that this part is 2 centimeters, which means that this green line over here would be 8 minus 2, so that gives me a 6. So to calculate the diagonal or the hypotenuse squared is equal to side 1 squared, so 8 squared plus side 2 squared, which is 6. So the hypotenuse squared is equal to 8 squared plus 6 squared is 64 plus 36, which is 100. Then what I would do is I would then square root both sides of this equation. So the square root of h squared is h, and that is equal to the square root of 100, which is 10 centimeters. Which means that I have 10, 10, 10, and 10 because the triangles are congruent. So therefore, if I was doing the perimeter, it would equal all of the sides added together, but I have 4 of the same sides with the 10, and I have 4 of the same sides with the 2's as well. So that means that the perimeter would equal 10 times all 4 of them plus 2 times the 4 of them. So the total perimeter comes to 48 centimeters. In this next question, we have the diagram shows a square ABCD of side 8 centimeter inside a circle center O. So we have the word center O again. The vertices of the square lie on the circle. Work out the total area of the 4 shaded segments. Give your answer correct to 3 significant figures. Alright, now if we are trying to calculate or determine the total area of the shaded segments, the best way to do this would be to determine the area of the whole circle, then determine the area of the square inside the circle and subtract the area of the square from the area of the circle. So that will be the best way to do it. In order to calculate the area of either of those shapes, we need to know what the formula would be. So the area of a square is equal to length squared. So we have the length, so we'd be able to calculate the area of that square. However, the area of the circle is equal to pi r squared. So in order to determine the area of that circle, we need the radius. Now, if we look at our radius, we have 4 radii drawn here for us. We have OB, OC, OD, and OA. Now what we need to do is we need to determine one of those radii. Now the easiest way to do that would actually be to determine the diameter. Alright, so I'm going to determine AC because AC is the diameter. Once I have AC, I can divide it by 2 so that I can get the radius measurement or the radius length so that I can substitute it in place of this radius in pi r squared. The reason that will be able to be helpful is because I have the length of all of the sides of the square, 8 by 8 by 8 by 8, which means that I could work in triangle ABC and I could work in a right angle triangle. Now there are 2 reasons why it's a right angle triangle. Number 1, because of angles in a semicircle, because AC is a diameter, which means that it subtends a 90-degree angle at angle B, so angles in a semicircle. Alternatively, we were told that it's a square, so therefore we know that all the interior angles are 90 degrees. Working in triangle ABC. I know that AC squared is equal to side 1, which is AB squared, plus side 2, which is BC squared. Alright, so AC squared is equal to AB is 8. So I have 8 squared plus BC, and BC is also 8, so that is squared. So AC squared is equal to 64 plus 64, which is 128. But I don't want AC squared, I want AC by itself, so that means that I'm going to square root both sides of this equation. So the square root of AC squared is AC, and that is equal to, when I square root 128, I'm going to keep it as a third so that I can keep all my decimals. So I have 8 root 2, and the unit would be centimeters. So now I have AC's length. So having AC's length means that I can therefore conclude what my radius would be. So I would say, therefore, my radius would equal 8 root 2 divided by 2. So I have a radius of 4 root 2 centimeters. So now that I have my radius, I'm able to calculate the area of my circle. So I'm going to calculate the area of my circle, I'm going to calculate the area of my square, and I'm going to subtract them from each other. So if I'm doing the area of my square, that is equal to length squared. The length is 8 squared, and 8 squared is 64 centimeters squared because it's area. Then I'm going to do the area of the circle, and the area of the circle is equal to pi r squared. So that is equal to pi. The r is 4 root 2, and that is squared. So therefore the area of the circle is equal to, and I'm going to keep it with the pi so that I keep all my decimal places. So it's 32 pi centimeters squared. Now that I have the area of the square and the area of the circle, I can therefore conclude the total area. And that is equal to the area of the circle, which is 32 pi, minus the area of the square, which is 64 centimeters squared. So that comes to three significant places, 36.531 centimeters squared. Alright, for the next question, we have the diagram shows a shape made from triangle ABC and a semicircle with diameter BC. So I have a diameter BC. Don't forget, it's a semicircle, so that means it's half of a circle. Triangle ABC is right angled at B. AB equals 7.6 centimeters and AC equals 9.5 centimeters. Calculate the area of the shape. Give your answer correct to three significant figures. Alright, so we are calculating the area of the shape, and this shape is broken up into two parts. So we have part 1, which is a triangle, and we have part 2, which is a semicircle. So that means that we would need to calculate the area of the triangle, the area of the semicircle, and add them together. So the difference between combined area we're going to add together, as opposed to the previous question, which was shaded area, where we subtract from each other. Alright, now in order to calculate the area of this triangle, the area of a triangle is equal to a half base times perpendicular height. So now we have the 7.6, which could either be the base or the perpendicular height, depending on how you turned your triangle. So that means that we are requiring the line or the length CB. So we need CB so that we have the base and the perpendicular height. CB will also be the diameter of the semicircle, or of the circle, and we can divide that by 2 to get a semicircle. Alright, so that means that we have to start by determining or calculating BC or CB. So we're going to use Pythagoras, and it's one of the shorter sides. So it's the shorter side, so I have in triangle ABC. I'm looking for the shorter side, so I'm looking for CB squared. So that will equal the hypotenuse, which is AC squared, minus the other short side, which is AB squared. So CB squared is equal to AC, which is 9.5 squared, minus AB, which is 7.6 squared. So that means that CB squared is equal to 9.5 squared minus 7.6 squared, which gives me 32.49. But I don't want BC squared, I want the BC by itself, which means that I'm going to square root both sides so that I can isolate the CB. So the square root of CB squared is therefore equal to CB. And the square root of 32.49 is 5.7. Now I have BC's length being 5.7, so I can put that on my diagram. Alright, so I can now work out the area of my triangle as well as the area of my circle. So the area of my triangle is equal to a half base times the perpendicular height. So that is equal to a half times the base, which is 7.6, times the perpendicular height, which we've just calculated now as 5.7. So that gives me an area of the triangle being 21.66 centimeters squared. I can also calculate the area of the semicircle. And that is equal to the area of a normal circle, which is pi r squared, but it's a semicircle, so I'm going to divide it by 2. So that gives me pi. The radius of the circle is equal to half the diameter. So the radius is equal to the diameter, which is CB. So 5.7 divided by 2. So the radius of this circle is 2.85. So I have 2.85 squared, but it's a semicircle, so I need to divide the area by 2. Alternatively, I could have just calculated the area of the circle as is and then divided it by 2. But I get the answer for the area of the semicircle being 12.759. So that means, therefore, that the total area is equal to 21.66 plus 12.759. So that gives us an answer of 34.419 centimeters squared. The next question says that ABC is a right angled triangle. All the measurements are in centimeters. But now, if you look at the measurements, we have AB being x, BC being x plus 2, and AC being x plus 4. Use the information to form a quadratic equation of the form x squared plus ax plus b equals 0, where a and b are constants, which you need to find. Alright, so we're still working with a right angle triangle. We, however, have variables. However, those variables are all the same. So we only have x's, which means that we can form a quadratic equation in the form x squared plus ax plus b equals 0. So we're going to use Pythagoras to form this quadratic equation. So we're going to start with Pythagoras. So AC squared, hypotenuse squared is equal to side 1, AB squared, plus side 2, BC squared. So AC is x plus 4. So I have x plus 4 squared equal to AB, which is x squared, plus BC, which is x plus 2 squared. Now we are squaring a binomial. So we'll have x plus 4 all squared. So we have x squared. X times 4 is 4x, double it, plus 8x, plus 4 squared, which is 16, equal to. So this binomial became this trinomial when I squared it. Then we have x squared plus, because the signs are all positive, I can just write it out as is. First term squared, so I have x squared, multiply the two terms together, x times 2 is 2x, double it, plus 4x, and 2 squared is 4. So now I've taken this binomial and I've created this trinomial with it. Alright, so now I'm going to group all my terms together. So I want a 0 on the one side. So I have x squared plus x squared, which is 2x squared. Then this x squared becomes a minus x squared. So I'm left with x squared. I have 4x on this side. Then this positive 8x, when it goes across, becomes a negative 8x. So 4x minus 8x is negative 4x. And then I have a positive 4 on that side. The positive 16, when it goes across, becomes negative 16, and 4 minus 16 is negative 12. So therefore, A is equal to negative 4, and B is equal to negative 12. Next question, here are two right angled triangles. All the measurements are in centimeters. So we have one triangle being ABC, the other triangle being A plus 1, B plus 1, C plus 1. Write 2C in terms of A and B. Alright, so this is just a simultaneous equation. So we want 2C in the form of A and B, which means that we need to work with the two triangles separately. So if we work with the first triangle, we can get it in the form of C squared. So we can isolate the hypotenuse to make it C squared. So once we have C squared, we can then work in the second triangle, and we can put whatever we've determined for C squared in place of the second triangle where we see the C. So what we're going to do is we are now going to work with our first triangle. So we will have the hypotenuse squared. So the hypotenuse is c, so c squared is equal to the sum of the other two sides squared. So a squared plus b squared. Now we would be able to isolate the c by square rooting both sides. However, we can leave it as c squared equals a squared plus b squared, and that is from the first triangle. So that means if in the second triangle we see a c squared, we can replace it with a squared plus b squared. So in the second triangle, we have the hypotenuse squared, so c plus 1 squared is equal to side 1, which is a plus 1 squared, plus side 2, which is b plus 1 squared. Alright, so c plus 1 squared becomes c squared, c times 1 is 1c, double it, plus 2c plus 1 squared, which is 1, equal to first term squared, so we have a squared, a times 1 is 1a, double it, plus 2a, plus 1 squared, which is 1, plus first term squared, b squared, b times 1 is 1b, double it, plus 2b, plus 1 squared, which is 1. So now we can see in the second equation that I've just formed, I have a c squared, which means that I can now replace that c squared with this a squared plus b squared. So now I'm going to have a squared plus b squared, because I'm going to leave the plus 2c because I want to write 2c in terms of a and b. Plus 1 is equal to, then I'm going to just on this side, simply because I'm running out of space, I'm going to add this 1 and this 1 together to give me 2. So I'm going to have a squared plus 2a plus b squared plus 2b plus 1, which is 2. So now I'm going to reorder everything and I'm going to collect my terms. So I have an a squared on this side and I have an a squared on that side, but they're both the same sign, which means that irrespective of which way I take the a squared, they're going to cancel out. I have a b squared on this side, I have a positive b squared on that side. They're both the same sign, which means that they would cancel out. So then I have the 2c left equal to, what's left on the right hand side? 2a plus 2b plus, then this 2 stays on the right hand side, but this positive 1 when it goes across becomes negative 1, and 2 minus 1 is 1. So therefore 2c in terms of a and b is 2a plus 2b plus 1. Remember, in terms of means, if you say in terms of a and b, it means that a and b must be in your answer. Looking at the next question, it says the diagram shows a rectangle. So we have a rectangle, we have x as the width, and we have a diagonal of 12 centimeters. The perimeter of the rectangle is 28 centimeters. So now we have perimeter being 28 centimeters. Find the possible values of x. So possible values of x is telling me that there's going to be more than one answer for x. Give your values correct to 3 significant figures. When it says find the possible values of x, that tells me that I'm probably going to be working with a quadratic equation. Now, to work with a quadratic equation, we need to form that quadratic equation. Now, in order to form it, we need to know what we're working with, and we're going to be working with simultaneous equations as well. Alright, so the information that they've given us is that the perimeter is equal to 28 centimeters. So now, if I work with the formula for perimeter, the formula for perimeter is equal to 2 length plus 2 breadth or 2 width, depending on how it's given to us. So we're given width. So the perimeter is equal to 2 length plus 2 width. So if I look at this, I can tell that I've been given the perimeter's value is 28 centimeters, and I have the width is x. So what I'm missing is the length. Now, I have right angle triangles in this rectangle because a rectangle is made of 2 right angle triangles because the interior angles of a rectangle are equal to 90 degrees. So what I'm going to do is I'm going to start by determining the missing side in terms of x, and then I can work with the perimeter. So how I'm going to start is I'm going to start by letting the length equal y. Now that I have the length being y, I can determine the length in terms of x. So that length will be a shorter side. So that means that the shorter side, y squared, is equal to the hypotenuse, which is 12 squared, minus the width, or the shorter side, other shorter side, which is x squared. So that would mean, therefore, that y squared would equal 12 squared, which is 144, minus x squared. But in order to use this as a simultaneous equation, I would need to get the y by itself. In order to do that, I would need to square root the y squared so that the square root cancels with the square. However, on the right-hand side, I have a binomial, which means that I need to square root the entire binomial. Now, when you square root a binomial with a plus or minus in between, you can't say that this is 12 minus x. You can't square root each term individually, so we have to keep it as a square root. But now, that means that I have y in the form of x. So y is therefore equal to the square root of 144 minus x squared. Now that we have y in terms of x, we can work with the perimeter. So the perimeter is equal to 2 length plus 2 width. So the perimeter we have is 28 equal to 2 times the length, and the length is the square root of 144 minus x squared plus 2 times the width, and the width is x. So now what I'm going to do is I'm going to start reordering this. So I want to isolate that surd. So in order to isolate that surd, what I'm going to do is I'm going to take the 2x to the other side. So I'm going to have 28 minus 2x, and that will be equal to 2 into the square root of 144 minus x squared. But I don't want to have that surd anymore. I want to get rid of that surd. So in order to get rid of that surd, I'm going to do the opposite, which is square. So I'm going to square the left-hand side and the whole right-hand side. So if I square the left-hand side, I have 28 squared, which is 784. Then I multiply together and double. 28 times 2 doubled is negative 112x. Minus 2x all squared becomes positive 4x squared. So what I've done is I have taken this binomial and I've created this trinomial. So that square on the right hand side belongs to the 2. It's going to square it, which is going to be a 4, and it's going to square that entire surd. So I'm going to be left with 144 minus x squared, so that I cancelled the surd and the square out. Alright, now I'm going to get rid of those brackets. So I'm going to have 784 minus 112x plus 4x squared will be equal to 4 times 144, which is 576. 4 times negative x squared is negative 4x squared. Now I'm going to group my like terms. So I'm going to have 0 equal to, I have positive 4x squared on this side. This side is a negative 4x squared, so the negative 4x squared stays the same. The positive 4x squared, when it goes across, becomes a negative 4x squared. And negative 4x squared minus another 4x squared is negative 8x squared. The negative 112x, when it goes across, becomes positive 112x. And then we have 576, stays the same, stays first, stays positive. The 784, when it goes across, becomes negative. So 576 minus 784 gives me negative 208. I'm going to check whether everything is divisible by 2, by 4, or by 8 because of the coefficient of the x squared. And everything is in fact divisible by 8, but I'm going to divide it by negative 8 to get rid of that negative sign. So therefore, 0 will be equal to negative 8x squared divided by negative 8 is x squared, Positive 112, x divided by negative 8 is negative 14x. And negative 208 divided by negative 8 is positive 26. Now I'm going to be working with my quadratic formula. So I have a being 1, b is negative 14, and c is 26. So my quadratic formula is x is equal to negative b plus minus the square root of b squared minus 4ac all divided by 2a. So now I can substitute in. So x is equal to negative 14 plus minus the square root of negative 14 squared minus 4 times a is 1, times c is 26. And that is all divided by 2a, so 2 times a is 1. So I can just type that into my calculator, correct to 3 significant figures. X is therefore equal to 2.204, or x is equal to 11.796. The next question says the diagram shows a rectangle. So telling us that it's a rectangle tells us that it has 90-degree angles. It also tells us that the diagonals of a rectangle are equal. The width of a rectangle is x centimeters and its length is y centimeters. The perimeter of the rectangle is 10 centimeters. The length of a diagonal of the rectangle is 4 centimeters. So we have the length of the diagonal being 4 centimeters. So that means that I would draw in a diagonal, and that diagonal is 4. Now it doesn't matter which diagonal we draw in because a rectangle has equal diagonals. So now it says show that ax squared plus bx plus c equals 0, where a, b, and c are integers to be found. So what we're going to notice is we are going to notice that we have x and y. Now, the minute that we have an x and a y means that we're going to be working with simultaneous equations. So to work with simultaneous equations, we're going to determine which simultaneous equations are going to give us our solution that we're requiring. So they've given us the perimeter of the shape. They've told us that the perimeter is 10 centimeters. So that means that we are definitely going to be using the perimeter as one of our simultaneous equations. The other simultaneous equation is they've given us a diagonal with 4 centimeters, which means they've given us the value of 4. So we're going to use Pythagoras in one of those two triangles. So if we start with our perimeter of a rectangle is equal to 2 length plus 2 times the width. So the perimeter they've given us is 10 is equal to 2 times the length is y, plus 2 times the width is x. So we have 10 equal to 2y plus 2x. We can therefore divide everything by 2. So 10 divided by 2 is 5, equal to 2y divided by 2 is y, plus 2x divided by 2, which is x. So now we have 5 equal to y plus x. So we need to determine, we could make x equal to 5 minus y, or we could make y equal to 5 minus x. We could isolate the x or the y. Now we need to decide whether we're going to isolate the x or the y because we want to decide what we want to be working in terms of. So if I isolate the x, I'll be working in terms of y. If I isolate the y, I'll be working in terms of x. And I want my answer to have x's in it, which means I need to work in terms of x. So therefore I'm going to isolate the y. So y will be equal to 5 minus x. So that means, therefore, that now I have y in terms of x, which means that I can work with Pythagoras. And I can say, therefore, that the hypotenuse squared, so 4 squared, that's the hypotenuse, is equal to side 1, which is x squared, plus side 2, and side 2 is 5 minus x all squared, because it would be y, this is side 2, the side 2 is the y, and we're saying that y is equal to 5 minus x. So 4 squared is 16, equal to x squared plus 5 squared, which is 25. 5 times negative x is negative 5x, double it, which is negative 10x. And negative x squared is positive x squared. So now I can isolate it. So I can say 0 is equal to, collect my x squareds. I have an x squared and an x squared, so that gives me 2x squared. Minus 10x. And then I have 16 and the positive 25. So the positive 25 stays the same. The 16 becomes negative 16. 25 minus 16 is positive 9. Now I would check if I could get rid of that coefficient of the x squared, but 9 is not divisible by 2. So therefore, A is 2, B is negative 10, and C is 9. In the next question, A, B, and L are points on a circle center O. So we have center O, so that reminds us of our center theorems. AB is a chord of the circle. M is the midpoint of AB. So if M is the midpoint of AB, then that means that this angle created or subtended would be 90 degrees, because a line drawn from the center to the midpoint of a chord is perpendicular to that chord. LOM is a straight line. AB equals 24 centimeters, so that means that AM and MB are each 12. Calculate the diameter of the circle. So now we can see that the diameter of the circle is not LM because there's a piece missing over here. So that means that the diameter is not 18, which means that we would need to be able to work with something else. O is the center of the circle, which means that OA would be a radius, which means that I would be creating a right angle triangle OAM. Now, if I were to say to you that the radius of the triangle is unknown, if I have an unknown radius, then that means that I have a radius of length x, or a, or b, or any variable, because I don't know what the length of that radius would be. The other thing that I know is that LO is also a radius, because it goes from O, which is the center, to L, which is the circumference, which means that LO is also x. From O to L is x. But I know that the whole length of LM is this 18 over here, which means that OM would be the full length, which is LM, so that's 18, minus whatever the radius is, minus this part, minus the x. So now I have 3 sides of the triangle, and each of them have a letter, the same variable, have x and a number. So I would start by stating that angle OMA is equal to 90 degrees because it's the line from the center to the midpoint. So that means that it's perpendicular. So now I can start and work in a triangle. So I'm going to work in triangle AMO. So if I'm working in AMO, which is a right angle triangle, I know that the hypotenuse squared, so OA squared, is equal to side 1, which is AM squared, plus side 2, which is OM squared. So OA is x, so x squared is equal to AM, which is 12 squared, plus OM, which is 18 minus x squared. So now I will be able to solve for x. So I have x squared equal to 12 squared, which is 144, plus 18 squared, which is 324. 18 times negative x doubled is negative 36x. Negative x all squared becomes positive x squared. Now what I would notice is that I have a positive x squared on the left and a positive x squared on the right, which means that those are going to cancel. So that means I'm going to take the negative 36x to the left-hand side, so it becomes a positive 36x is equal to 144 plus 324 gives me 468. So now what I'm going to do is I'm going to divide both sides by 36. So 36x divided by 36 is x equal to 468 divided by 36 is 13. So therefore the radius, because x is the radius, is equal to 13 centimeters. The question, however, doesn't ask for the radius. The question asks for the diameter. So therefore the diameter is equal to 13 times 2, which is 26 centimeters. The diagram shows a right-angled triangle. The length of the base of the triangle is 2 root 3 centimeters. The length of the hypotenuse of the triangle is 6 centimeters, and the area of the triangle is a centimeters squared. Show that a is equal to k root 2, giving the value of k. We want the value of k, and we have k being in the area, so we are going to be working with the area of this triangle. Now, in order to work with the area of the triangle, we need to know that the area of a triangle is equal to a half base times perpendicular height. So that means we need this perpendicular height over here. We need that value. So in order to get that value, we're going to start with Pythagoras. So I'm going to call this perpendicular height x. So x squared is one of the shorter sides of the triangle, is equal to the hypotenuse squared, so 6 squared, minus the shorter side, which is 2 root 3 squared. X squared is equal to 6 squared minus 2 root 3 squared, which is 24. But I don't want x squared, I want the x by itself, so I'm going to square root. So when I square root both sides, the square root of x squared is x, and the square root of 24 is 2 root 6 centimeters. So now I want to work with the area of the shape. So the area is equal to a half base times the perpendicular height. So the area is equal to a half. The base in this question is 2 root 3 times the perpendicular height, which is 2 root 6. So therefore, the area is equal to a half times 2 root 3 times 2 root 6 gives me 6 root 2 centimeters squared. Now the question said that the area is k root 2, give the value of k. So our area is k root 2, so this is k root 2, so therefore k's value is 6. The next question says that the diagram shows a solid cone. The diameter of the base of the cone is 10a centimeters. The height of the cone is 12a centimeters. The total surface area of the cone is 360 pi centimeters squared. The volume of the cone is k pi centimeters cubed, where k is an integer. Find the value of k. Alright, so in this question, we are working with surface area and volume of a cone. So if we look at our surface area of a cone, that is equal to pi r into r plus s, and s is the slant height. To determine the slant height, we're going to have to use Pythagoras. We also have the volume of a cone, and the volume of a cone is equal to a third pi r squared times h. So we have the surface area being 360 pi, we have the volume being k pi. If we look at our formulas that we have, we can determine what we still need. We were given that the diameter is 10a, so that means that the radius is therefore equal to 10a divided by 2, which is 5a. So that means that we have the radius for that formula, and we have the radius for that formula. We also have the surface area given to us in the question, and we have the volume given to us in the question. If we keep looking at the question, we have the height, which is 12a, so we have this height over here. So we have the 12a, which means we have what we need for the volume. However, the volume is still in terms of k. If we look at the surface area, what we're missing in the surface area is we are missing the slant height. So that's where we're going to start. We're going to start by determining the slant height. So if I were to show you what it would look like as a little sketch, we would have a triangle like that. So we have our height, which is 12a. We have our radius, which is 5a. And this over here is our slant height. So we want to determine our hypotenuse over here. So our slant height will be hypotenuse squared is equal to side 1, which is 5a squared, plus side 2, which is 12a. And that is also squared. So the slant height squared will equal 5a all squared plus 12a all squared. So 5a all squared is 25a squared plus 12a all squared is 144a squared. So we have the slant height squared being 25 plus 144a squared is 169a squared. So now what I'm going to do is I'm going to square root both of these sides of this equation. So the square root of s squared is therefore equal to s. So the slant height is s equal to the square root of 169a squared. Square root of 169 is 13. Square root of a squared is a. So now I have a slant height being 13a. So now we're going to substitute into our formula for surface area and volume. And we are going to determine our unknowns. So the surface area that they gave us is 360 pi. That is equal to pi r, which is the radius, which is 5a. That is multiplied into r plus s. The radius is 5a. The slant height is what we just determined, which is 13a. So now what I can do is I can divide both the left-hand side and the right-hand side by pi to get rid of the pi. So if I divide the left-hand side and the right-hand side by pi, that means that the pi's are going to cancel. So on the left-hand side, I'll be left with 360 is equal to the 5a into, and then what I'm going to do is I'm going to add this 5a and this 13a together to give me 18a. So 360 is equal to 5a times 18a. 5 times 18 is 90. a times a is a squared. Now what I'm going to do to isolate the a is I'm going to divide both sides by 90. 360 divided by 90 is 4, equal to a squared. But I want to get the value of a, so therefore I'm going to square root both sides. So therefore a is equal to 2 centimeters. Now I've got a to calculate k, because if I look at the formula for the volume that I have, volume is equal to 1/3 pi r squared times h. Because the volume that they've given us is k pi, equal to 1/3 pi r. R is the radius, which is 5a squared, times the height, which is 12a. So you can see that in the volume formula, we have two unknowns in the k and the a. So what we're going to do is we're going to replace at the end the a with the a value that we've determined, so that we're able to substitute the a and calculate the k. Alright, so what we're going to do is we're going to start by getting rid of that third, and to get rid of the third, I'm going to either divide both sides by 1/3 or I'm going to times both sides by 3. So k pi times 3 is 3k pi equal to pi, because now I've cancelled by timesing by 3, I've cancelled out this third. I have 5a all squared, which means that I'm going to multiply the pi with 25a squared times 12a. Now what I can do is I want to get rid of this pi on both sides, so that means that I'm going to divide both sides by pi. So dividing by pi means that I'm going to now get rid of the pi on both the left hand side and the right hand side. So I'm going to be left with 3k equal to 25a squared times 12a. 25 times 12 is 300. A squared times a is a cubed. To isolate the k further, I'm going to now divide both of these sides by 3. So therefore, 3k divided by 3 is k equal to 300a cubed divided by 3 is 100a cubed. But we have determined that a is equal to 2. So therefore, that means that k is equal to 100. In place of the a, I'm going to put a 2 cubed. So therefore, k is equal to 800.